Since last some time back, I am receiving many requests or suggestions or advice from my many beloved friends all over the country, more especially some young engineers and some students. They are in fact requirement of some short questions and answers for preparing themselves in entrance examination, either for job opportunities or for higher studies. I feel very uncomfortable because I had no depth in engineering subject. I have little knowledge in geotechnical engineering only. Since last more than 50 years I am associating in geotechnical engineering only. I have forgotten all other subjects because I find some amount of pleasure to hear the sufferings of stressed soils. So I am preparing some short questions which may be useful or may not be useful for their specific purposes. Of course, it is very much delayed, mainly due to corona pandemic. Here, another thing I want to mention that in this there are innumerable, not only innumerable, it is beyond countable. Errors and typing mistakes are there, and I am completely unable to edit due to manpower crisis, mainly because of present corona pandemic. This short question and answers I am preparing in few parts. Today I shall going to discuss about on first part 1. Question 1. Coarse grain sands are basically derived from chemical weathering, mechanical weathering, glacial activities, climate changes, or none of this. We know that soil basically derived from the weathering of parent rock mass. So, coarse grain soils are mechanical weathering, derived from mechanical weathering. Fine grain soil less than 2 micron, derived from biological process, chemical weathering, decomposition of humus, climate changes, or none of these. These are answers. Fine grain soils are basically derived from chemical weathering. Question number 3 and 4, you see, match question 3 and 4. Soil is semi-infinite because it extends infinitely in all directions below surface. Soil is homogeneous. It has identical properties in any identical direction. Soil is isotropic It has identical elastic properties in all directions. The soil is elastic. It contributes constant modulus of elasticity. Now, question number 5. The following process is termed as chemical or mechanical weathering. Given answer is hydration, releasing, oxidization, carbonation, and hydrolysis. Here it is, oxidization is wrongly typed. I am very really sorry, I could not correct it. So, these processes are chemical weathering process. Next question is match the following 6 with 7. In 6 there are some A is sandbar, B boulder bed at the bed, C dune of Rajasthan, D bharv clay, C Sundarban. You see, in 7, one is drift carried directly by ice. This is boulder bed. It has relationship with 1. Alluvium transported by a river. It is sandbar. Sand is normally transported by a river. Another is transported by wind. It is dune of Rajasthan. Another is glaciofluvial soil transported by glacier and finally deposited by water. Bharv clay. Sundarban. This is lacustrine deposit. Marl, which is transported by water and deposited at where velocity is almost 0. Now next question you see, A. Particles greater than 75 micron is called fines. True or false? No, it is not fines. When it is less than 75 microns, then it is fines. Particles less than 75 mm size is called cobbles. No. Option is there, yes or no? No. Particles greater than 50% passing 75 micron shape is called coarse grain sand. There are two options, yes or no. It is no. Dual symbol can be used, right or wrong. It is right. When necessary, when there are two characteristics, two behavior exhibits, we have to use dual symbol. SMSC, SW, GP, like that. Fine grain soil classified using plasticity properties. Option is yes or no? Yes. Fine grain soil which are less than 75 microns in size can be determined by plasticity characteristics considering plasticity index above A line or below A line. There are two types of fine grain soil. One is silt, another is clay. What type of soil classification system to use in India? Given answer is ASTM, textural, unified classification system, BS classification system, US Army crop system, any other system. Answer is 3. Unified classification system. If liquid limit is 55%, plasticity index is below A line, the soil shall be classified as given answer CH, CI, MI, MH, OH, and none of this. With these characteristics, we have to classify this soil MH, because for OH we are unable to confirm since other information is required. Next question, if liquid limit is 49%, plasticity index just at A line, the soil to be classified as CI, MI, CH, MH, dual symbols, or none of this. Yes, here we can use dual symbol, CI and MI, because since it is just at A line, somebody may consider it is above A line, somebody may consider it is below A line. So it is very doubtful. So it is dual symbol CI-MI. Coefficient of uniformity of sandy soil finds having 4% as 2, Cc is 3.5. The soil is classified as GM, SP, SW, GP, GC. This criteria shall fulfill the required condition of SP, so it is SP soil. Granular soil having 60% greater than 4.75 mm finds 15%, and IP is below A line. What will be the group? The given answer is SC, GC, GM, SM, dual symbol. Here you see, since it is more than 50% is gravel and fines is 15%, but it is below A line, so it is gravel and silt. Silty gravel, it is silty gravel, GM. Granular soil, gravel 20%, fines 3%, CU coefficient of uniformity is 6, coefficient of curvature 1.5, whether soil will be GP, SP, SW, GW or dual symbol. It is SW, well graded sand, because it is uniformity is 6 and it is 1.5. So it is well graded sand, SW. A mixed soil, gravel 55%, fines 8%, coefficient of uniformity 7, CC 2, IP above A line, whether the soil GC, GW, dual symbol, none of this. It is dual symbol. This is dual symbol. GWGC. It looks like well-graded gravel with some amount of clay. So, since it is more than 4 and less than 15, less than 12, so it is GWGC. Remember that if it is less than 4, this shall not be considered. Next question. Normally consolidated soil having void ratio of 0.6 to 0, the approximate compression index Cc. What shall be the approximate compression index Cc? Given in chart 1.105, 0.310, 0.120, 0.27 or 0.155. Because you see, when void index is given, Cc equal to 0.3 into this void index minus 0.27, from 6 to minus 0.27, remaining figure will be the 5. So 5 into 3, so this figure will be coming. So answer is 0.105. Normally consolidated clay WL equal to 40% and void ratio equal to 1. The approximate compression index Cc can be calculated with using two equations, which shall be these two equations we can calculate, which shall give lower value from given answer is liquid limit or void index. Actually it will give liquid, it will give lower value from this. So it is from liquid limit, A clay's moisture content at WL, the shear strength equal to 17 gram per centimeter square, and the same soil dried up to WP, this is plastic limit, WL means liquid limit, plastic limit. What shall be the shear strength? Given answer is 1.7 kg cm square, 0.17 kg cm square, 0.34 kg cm square, none of this. The maximum shear strength is obtained at soil moisture if it is at plastic limit, that is maximum shear strength. When it is coming 17 gram per centimeter square at liquid limit, moisture equal to liquid limit, then when moisture equal to WP of same soil, it will be the 1.7 kg and 7 kg per centimeter square. It is almost universal. A clay soil was tested at a moisture content equal to plastic limit and shear strength was calculated as 2 kg per cm square. If another clay soil tested at a moisture content of equal to a plastic limit, what shall be the shear strength? Given answer is same. B is plus minus 10%, plus 10%, minus 10%, none of this. Because here you see, in question, if another clay soil, so if it is another clay soil, we do not know the nature and behavior of that another clay soil. So in none of this, we cannot say anything. A clay soil having moisture content higher than liquid limit, the overburden pressure resisted by given inquiries pore water pressure, weight of soil, isotropic balancing system, lateral distribution of soil weight, none of this. The overburden pressure is resisted by shear strength plus pore water pressure. When soil is moisture content is more than liquid limit, it is already in liquid state. So shear strength in that soil, shear strength shall be 0. So overburden pressure is resisted by pore water pressure only. Yes or no? Void ratio has no role in foundation design. It is a wrong conception. Void ratio is an important parameter in foundation design. Excess soil moisture may produce crack on drying. Yes, when moisture is removed, there shall be some crack. If we look at paddy field during dry season, there are a lot of cracks are developed at the surface. Higher the density, higher the shearing strength. Answer is yes. Shear strength dependent on density of the soil. At a ground surface, C equal to 0 soil has no shearing resistance. What is the shearing resistance? Shear strength is C plus n tan phi. When C is 0 and whatever phi may be, overburden is 0. So 0 overburden multiplied by frictional angle shall not give any 0. Has no shearing resistance. C plus n tan phi. There is 0 plus 0 into tan phi. So ultimately it will be 0. So it is correct. Yes, at ground surface when C is equal to 0, the soil has no shearing resistance. Moisture content above sinkers limit suitable for compaction. Yes, if it is above sinkerage limit, but does not mean that it shall be more than liquid plastic limit. Our question is limited to above sinkerage limit. Legally we should not interpret. We should interpret when it is not close to plastic limit. Since it is a question of sinkerage limit only, so less than above sinkerage limit means legally it may be above liquid limit also, but technically above sinkerage limit means it is sinkerage limit. It is 1 or 2% more or less. Yes, it is suitable for compaction. Some soil underwater condition at the bottom, sea bottom or lake bottom for millions years together. During laboratory test, every time voids are found. Why? Given entire loss of soil moisture during sampling and testing due to evaporation and presence of free oxygen in water, no soil is 100% saturated. Under this condition, answer is no soil is 100% saturation. There some amount of air is there. This soil is constituent of three materials: solid, water and air. So there is some amount of air, so soil is not 100% saturated. At what moisture soil is suitable for construction materials? Moisture equal to sinkage, given answer is moisture equal to sinkage limit, moisture equal to plastic limit at OMC, close to OMC, none of this. Given answer is 2. It is at plastic limit. Plastic limit is always very negligible percent above the OMC. So it is, of course, if you write close to OMC or OMC, that is also right. Here it is 2 at plastic limit. During rolling of earthfill, soil heaps generally noticed. Why? Given insurance of moisture above the OMC, moisture equal to sinkage limit, moisture equal to plastic limit, moisture close to liquid limit, none of this. Here, answer is moisture above the OMC. Moisture above the OMC. So it is, there are some heave. In case as stated at C, what is the suitable effort can be made? Given answer, replace the soil, adding some crusher dust, allowing evaporation of moisture, adding calcium carbide, none of above. Best easy solution is replace the poor material with some good material. So answer is this. Or alternatively, we can allow the soil mass for evaporation of soil moisture, which may be time consuming. So technically replace the soil is best suitable method. Next question is, calcium carbide react with water, produce a gas. Answer is C2H2, CO, CO2, H2, or none of this. Answer is acetylene gas, C2H2, this C2H2 acetylene gas. Radial soil, normally top mantle of hills, any hills, any over. What type of soil is? Fissured, intact, barb, residual, or none of above. These are residual soils. Neither these are transported by any agencies or it is remain intact at the place of origin. So it is residual soil. Stroke law was used for analysis of particle size analysis finer than 75 micron. What is the IS code? IS 2720, IS 1892, IS 1948, IS 456, 456, none of this. We should remember only one thing, all testing method of soils are given in IS 2720. So answer will be this IS 2720 part. It is not PR, it is part 4. Soil moisture is proportional to voids in soil mass. Yes, मोर्डी voids, मोर्डी soil मध्य. The color of soil indicates the nature and pattern of soil. Name one type of such soil. Whitish, red, black, dark grey, none of these. There is one type of soil is there, black cotton soil. It is origin from the color, black cotton soil. Permeability of soil is important parameters for design of hydraulic structure, and these are pumping out, pumping in, and laboratory test. IS 5529, what type of permeability test recommended? In situ pumping in, in situ pumping out, laboratory permeability test, Pecker test, none of above. IS 5529 specifically recommended in situ pumping in test. What is lagoon? Rate of permeability at atmospheric pressure per meter length. Rate of permeability at 10 kg per cm square atmospheric pressure per meter length, or rate of permeability at 1 kg cm square atmospheric pressure per meter length. None of this. Lagoon is a common term basically used in hydroelectric project for dam construction. So it is rate of permeability at 10 kg per cm square atmospheric pressure per meter length. Seepage and permeability is same property of soil. No, because seepage is separate parameter and permeability is separate parameters. For seepage water flowing, there shall be some original roots, but permeability, it penetrates the soil voids and water going outside. So it is no. Permeability primarily depends on voids of soil mass. Yes, more the voids, more the soil is permeable. So sand has more voids, so sand is more permeable than clay. Coarse grain soil has more permeability. Yes. Rock has less voids, so rock is impervious. Yes. Permeability of bedrock depends on joints and fracture of rock mass. Yes. Rock is impervious. Impervious means not 100% impervious, but it is very negligible. But yet, in rock bed, there is some amount of permeability was noticed only because of joints and fracture of rock mass. So it answer is yes. Angular sand is less permeable than round sand. Yes. In angular sand, voids are less, and round sand, voids are more. Clay has permeability less than 10 to the power minus 7 centimeter per second. Yes, it is almost impervious. Cement grouting in joints of rock permeability became approximately nearest to zero. Yes, when joints are filled with cement grouts, it behaves like monolithic behavior. There is no joints and fractures. So it became very less permeable, almost nearer to zero. A granular soil having an angle of repose of 28 degree and the frictional angle of same soil at the loosest state almost equal to, given answer is 28 degree, 30 degree, 25 degree, none of this. The angle of repose and angle of internal frictional angle, these are quite different, but the angle of frictional angle of loosest state, sand of loosest state, when it is almost those who are simply damp soil, that is equal to angle of repose. So answer is 28 degree. A cohesive clay phi equal to 0 has unconfined compressive strength UCS is 20 MPa. Therefore, shear strength nearly equal to, and given answer is 10 MPa, 15 MPa, 20 MPa, and none of this. When phi is 0, C plus n tan phi, when n tan phi will be 0, so there will be C only. So this UCS S equal to UCS divided by 2. So it is 10 MPa. Correct answer will be 10 MPa. In a triaxial shear test, Newton's law is used for estimation of applied stress. Given answer is sigma 1 plus sigma 2, sigma 1 equal to sigma 2, sigma 1 plus sigma 2 plus sigma 3, sigma 2 equal to sigma 3, none of this. This correct answer is sigma 1 is applied pressure and sigma 2 is upward pressure, that is which is base, from pressure given by base. It is always sigma 1 is equal to sigma 2. Hooke's law is generally used in UCS or triaxial shear test for estimation of stress-strain relationship, to estimate elastic modulus, etc., to estimate the Poisson ratio, or to estimate the frictional angle. Stress-strain relationship is primarily necessary to estimate the elastic modulus. So answer is to estimate the elastic modulus. This is estimate the elastic modulus is a resultant of stress-strain relationship. In UCS or undrained triaxial shear test, the diameter of test specimen considered proportionally increasing with the decrease of length of test specimen because water is incompressible, primary permeability is very low, measurement of lateral dimension very approximate during test operation, non-uniform changes of diameter, and none of this. Water is incompressible. So we are arithmetically derive the diameter of the test specimen considering water is incompressible. What compressible decrease in length is only because of compression in soil mass. A pure rich plastic clay cannot be tested under 100% drained out condition because of very low permeability. During draining out, the test specimen generally disturbed. 100% drainage not required in analysis. It does not affect in shear strength. None of this. Ensure is very low permeability. We cannot drain out 100% because of very low permeability. In a box shear test, direct shear test, the test specimen is severely disturbed during specimen preparation of granular soil but it is preferable because it is very difficult for perfect UGS sampling, about 90% accuracy. It is included in IS code. For rough estimation, none of this. In my opinion, except is the IS code is there, it is conducted everywhere. During my last more than 50 years of my professional life, I never rely direct shear test with regards to Dr. Tarzaghi or all other Kasagande and everyone. With great regards, I am not using direct shear test results. It is, since it is included in the IS code. So, for me, my answer is it is included in the IS code. The frictional angle phi of a granular soil primarily depends on relative density, particle shapes, soil moisture, particle arrangement, none of this. Answer is relative density, because relative density, for estimation of relative density, particles arrangements, particle shapes, soil moisture, all are related. For all relating these factors, relative density is resultant. So, for frictional angle, for relative density is primarily depend on relative density. A granular soil minimum depth of foundation DF is determined by density and frictional angle phi. But in case of cohesive soil, DF may be determined. Given answer is using density and frictional angle, density and angle of repose, theta, or density and shear strength, density and width per length, or none of this. That can be derived from considering taking density and angle of repose. That is the equation is by the P pressure divided by unit weight and 1 minus sin theta and divided by 1 plus sin theta. From that equation we can calculate the depth of foundation for cohesive soil where phi is 0. Settlement of a normally consolidated soil entirely dependent on compression index Cc, thickness of stratum, compressibility coefficient, pressure intensity, void index. All components are required, but primarily dependent on compression index Cc. Compression index Cc. More the compression index, more the settlement. In a pre-consolidated soil, a settlement was estimated as 10 millimeter against a loading intensity of 1 MPa. Then what shall be the settlement against a pressure intensity of 2 MPa having same foundation dimension? Pressure intensity will be same. If pressure intensity shall be increasing, dimension will be same. So here it is 10 millimeter. What shall be the settlement for 2 MPa having same foundation dimension? Given answer is 50 mm, 25 mm, 20 mm, 30 mm, none of this. Here we must see it is normally consolidated soil. It is pre-consolidated soil. In case of pre-consolidated soil, our principal component is PBMV. If P is more, settlement will more. If B is more, settlement will more. And MV, if MV is same, there are changeable parameter is B and P. So here P is double, so settlement of 10 millimeter will be, here it will be, answer will be 20 mm. In normally consolidated clay soil, the settlement was estimated as 20 millimeter against a loading intensity of 1 MPa. Then what shall be the settlement of same soil for a loading intensity of 2 MPa having same foundation dimension? 40 mm, 50 mm, 60 mm, 30 mm, but none of this. Because it is, you see, it is in case of pre-consolidated, it shall be the straight double. But it is normally consolidated, there will be this equation will be Cc H0 divided by 1 plus E log P by effective overburden pressure. So this, when these factors are there, it cannot be a very short question. It will require minimum 5 minutes. So none of these. Correct answer will be none of this. A net allowable bearing capacity has been worked out as 1.5 kg per centimeter square, adopting a safety factor of safety of 3 against a settlement of 20 millimeter. The actual pressure intensity expected to be slightly higher. In such cases, whether the net allowable bearing capacity may be taken as 1.8 kg per cm square, 2 kg per cm square, 2.5, 3 kg per cm square, none of this. Because we can reduce the safety factor. 3 is applied. We can go for 2.5 as per caudal provision. If we divided by 2, instead of 3, if we adopt 2.5, then it will be coming 1.8. 1.8. So we can adopt 1.8. Net allowable bearing capacity of granular soil calculated using figure 9 of IS 800 part 1 as 1 MPa against a settlement 10 millimeter settlement. In case of permissible settlement as per IS 1904 is 40 millimeter, what shall be net allowable bearing capacity? Is it 4 MPa, 2.5 MPa, 3 MPa, 5 MPa? None of this. As per this code, it is, since it is 1 MPa and settlement is 10 millimeter and permissible is 4, so the correct answer will be 4 MPa. This is 4 MPa. In a pre-consolidated hard clay, settlement was calculated as 10 millimeter against a pressure intensity of 1.5 MPa, a foundation size of 2 by 2 meter. During construction, foundation size changed to 4 meter by 4 meter with same pressure intensity of 1.5 MPa. Calculate the settlement of new foundation considering same soil deposit mass below. Here it is 1.5 MPa is 10 mm for 2 by 2, and here it is 4 by 2. That means increment is double. I said earlier the P, B and MB. So here B is increasing 2 times. So multiplied by 2, it is 20 mm. An elastic settlement of foundation 2 by 2 meter for pressure intensity of 1 MPa was calculated as 10 mm. Now if pressure intensity increased to 20 MPa, the settlement of the foundation, what shall be the settlement of foundation? 20 millimeter, 30 millimeter, 40 millimeter, 50 millimeter, none of this. You see, it is elastic settlement can be calculated out using elastic modulus only. Since elastic modulus of that soil is constant and other is P and B, so here it is P is increasing. Instead of 1 it is increasing to 2. So ultimately this 10 millimeter shall be 20 mm. As stated in F, but foundation size increased to 5 by 5 meter without change in pressure intensity, the settlement of 5 meter by 5 meter shall be equal to 10 divided by 2 into 5. These are the answers. 10 divided by into 5, 10 by 2 into 2 into 5 by 5. Next is 10 by 2 divided by 5, none of this. It is, answer is 10 by 2 into 5. Earlier it is calculated for 2 by 2 foundation size, and now it is 5. So 10 divided 5 by 2 into 5. We will be getting correct results. Foundation was loaded up to 1 MPa and the settlement was recorded as 15 millimeter. Subsequently, the load was removed to 0. Now the final settlement was recorded at 10 millimeter. Now calculate the elastic settlement of the foundation. Given answer is 5 millimeter, 10 millimeter, 15 millimeter, 25 millimeter, none of this. What is the total settlement? Total settlement, this elastic settlement plus compression settlement. When it was recorded as 15 millimeter and when unloaded, when P is 0, then it is recorded as 10 millimeter. So this total elastic settlement is 5 millimeter. That means when it is loaded, it will be 15 millimeter, and when released, it will reduce to 5 millimeter. A granular soil having frictional angle equal to 30 degree and the depth of foundation was calculated as 2 meter below ground level for a pressure intensity of 1 MPa. What depth of foundation safely be provided for a pressure intensity of 2 MPa, 4 MPa? No, for 2 MPa, answer is 4 meter, 3 meter, 3.5 meter, 4 meter, none of this. This answer of none of this is this, because we have to calculate, we have to make some calculation to calculate the pressure intensity and depth of foundation. Using all these parameters, it will take time consuming. For 1 mark, answer is none of this. A cohesive soil C equal to 1 MPa, angle of repose equal to 30, frictional angle equal to 0, depth of foundation was calculated as 1 meter below ground level for pressure intensity of 1 MPa. What shall be the minimum depth of foundation if pressure intensity increases to 1.5? Answer is 1.5, 2 meter, 2.5 meter, 3 meter, none of this. You see, when phi is 0, C is 1 MPa, and we required, and depth of foundation was calculated as 1 meter. When it will be to 1.5 MPa, then depth of foundation shall be 1.5 meter. All natural slopes are stable. Is it yes or no? It is yes, all natural slopes are stable. Angle of repose of slope soil is deciding factor for slope. Yes or no? Yes, angle of repose is a deciding factor. For a clay soil, height of slope has also important role. Yes or no? Yes. In case of clay soil, height has an important, including the angle of repose. Up to a certain height, angle of repose is responsible, and in case of granular soil, angle of repose is 100% responsible. But in case of clay soil, after a certain height, we have to consider the slope as well as other factor, also height as well as C and phi, all the factor we have to consider. Next question is, sleep cycle method is more useful in slope stability analysis. Yes, this is most popular method all over the world for stability analysis. In most cases, slope failure retaining wall is not effective. In most of the cases, retaining wall is not effective, so answer is yes. Plantation is best for soil nailing method for slope stability. It is yes, plantation is best suitable method for soil reinforcement as well as to absorb soil moisture during monsoon period. Taylor's stability number is simple method of slope stability. Yes. Just you give the number and height, automatically it will calculate So it is very simple. Just 1 minute is required. Human destruction is the main reason of recent landslide all over the world. Answer is correct. In the name of our development, we are destructing whole reserves, hills, forests, and everything. Fissured soil is very prone to landslide. Yes, fissures means cell-like formation, sheets-like formation, one sheet upon another sheet upon another sheet. So one sheet is damaged or slides out, whole entire hill slides. Carbonaceous clay soil prone to slide and saturation. Yes, carbonaceous soil is very prone because the nature of carbonaceous soil, when it is dry, it behaves like shell, and when it is saturated, it behaves like very soft, compressible clay. So it is very prone to slide. Net shape bearing capacity of 2 meter by 2 meter footing over a clay phi equal to 0 as 1.5 MPa, and what net SBC shall be adopted for 3 meter by 3 meter footing 1.5 MPa given in chart. Mark the given in chart: 1.5 MPa, 0.75 MPa, 3 MPa, none of this. Because you see here it is when phi is 0, second and third component will be 0. Because NQ minus 1 Q plus half gamma B n gamma. When n gamma will be 0, third component will be 0. When NQ will be when phi is 0, NQ will be 1. In such cases 1 minus 1, it is 0. So second and third component of SBC shall be 0. So and same soil pressure what is deriving from C can be adopted. But remember another thing, it is a net shape bearing. There are two types of shape bearing. One is net shape bearing, another is gross shape bearing. If it is gross shape bearing, that overburden pressure shall be included. Net shape bearing capacity of 1 meter by 1 meter footing over a C equal to over a soil C equal to 0. The AC, BQ, CY. Using this equation, this component, AC component will be 0. It will be coming from the depth of foundation, and it will be coming from the size of the foundation. What net SBC shall be adopted for 2 meter by 2 meter footing? AC, BQ, CY, this one, or AC, BQ, 2CY, AC, 2BQ, CY, 4AC, 0.5 BCY, none of this. The same equation we have to adopt. AC, this equation, AC, BC, CY. This will be applicable. A granular soil when C equal to 0, phi equal to 36, extending up to sufficiently below, how much net shape bearing capacity can be adopted at ground surface level? Here interestingly you see C equal to 0, phi equal to 36, and SBC can be required at ground surface level. Given answer is 0 MPa, 0.5 MPa, 1 MPa, 1.5 MPa, none of this. As I told earlier, at ground level C plus n tan phi. If it is C is 0, if it is some n is there, then there will be some shear strength. But n is 0. So n tan phi equal to 0. So here it is SBC will be 0. Granular soil, if C is 0 at ground surface level, the SBC shall be 0. Stress distribution below foundation is proportionately equal to Bosson's stress factor, which equal to this equation, Q by B plus Z square. This is Z, this is this. So because this is it is 30 degree, it is 30 degree, it is distributing in this way, so ultimately this factor will be Z. So B plus Z. Now Q is 1.6 MPa, B is 1 meter, Z is 1 meter. Calculate the pressure intensity at a depth Z under foundation. Given answer is 0.4 MPa, 0.2 MPa, 0.8 MPa, 0.16 MPa, none of this. You see, it is 1.6 when B was 1 square meter. Now our B will be 4 square meter, 1 plus 1 square, 1 plus 1 square. So 4 square meter. When we divide 1.6 by 4, it will be 0.4 MPa. Next question, uniformly an applied load of 2 MPa on a square foundation produce a pressure intensity of 0.5 MPa at a depth of 3 meter below foundation. But during construction, the applied load was increased to 4 MPa. Calculate the pressure intensity of overloading at same depth. 1 MPa, 0.75 MPa, 1.25 MPa, 2 MPa, none of this. This shall be, here it is, you see, 2 MPa square foundation, and it is 4 MPa. So that was pressure intensity was 0.5. So here it will be 1 MPa, it will be double. Pressure is increased, instead of 2 it is increasing to 4. So when it is double, it will be automatically increased to 1 MPa. Pressure intensity below foundation decreasing as per Z by B ratio and as per Bosson's stress distribution theory. The pressure intensity of strip foundation is almost double than that of square foundation. It is important. The pressure intensity of strip foundation is almost double than that of square foundation. An uniformly loaded 1.5 MPa loaded strip has been worked out as 0.8 MPa at a depth of 2 meters below foundation. What will be the pressure intensity of 2 by 2 meter foundation at a depth 2 meters below the foundation? You see, in question it is already stated the double. So when it is double. In case of strip foundation, it is double than that of square foundation. So we have to calculate for square foundation. This divided by 2, it is 0.4 MPa. Pressure intensity of a uniformly loaded circular foundation at zero depth of R by Z equal to 10. Now a tunnel is required to be constructed where a 5-meter dia circular water tower foundation was already constructed. At what depth tunnel can be constructed safely? 100 meter below, 50 meter below, 25 meter below, 75 meter below, none of this. You see, in this entire equation, no output was given except some sizes. So correct answer shall be none of these. Necessary guidelines for construction of foundation at hills are furnished in different codes of practice in almost all countries. What is the code in practice in India is suitable? 1904, 6403, 1892, 2131, none of this. The guidelines for foundation, safety of foundation is given in IS 1904. So Indian only code. What simpler area is preferable for collection of undisturbed soil samples? Less than 10%, 15%, 20%, 25%, none of this. It is less than 10% is more preferable for using as an undisturbed sampler. Flood discharge Q is generally velocity into area, and calculate the velocity is calculated on the basis of hydraulic mean depth R is required. The river width is 1000 meter and uniform depth of water is 10 meter. What shall be the area? 10,000 square meter, 15,000 square meter, 20,000 square meter, 25,000, or none of this? Because area will be A will be B plus H. H is uniform. Somewhere it may be 9 meter, somewhere it may be 9, 10, 11 meter, but in uniform depth is 10 meter, so it will be 10,000 square meter. A Rcc canal with both side vertical Rcc wall and the width of the canal is 10 meter. The depth is 3 meter. How much discharge can be passed with a velocity of 1 meter per second? Answer is 30 cubic meter per second, 25 cubic meter per second, 20, 15. Answer is 10 into 3 into 1. That is 30 cubic meter per second. A road bridge was planned over river having design flood discharge of 15,000 cubic meter per second. Sill factor was adopted as 1. The maximum scour depth for pier foundation has been worked out as 11 meter below HFL using equation dm equal to 2 multiplied by db square divided by f. But during construction it was noticed that the sill factor is 2 and earlier sill factor 1 was wrong. Now what shall be the actual maximum foundation depth for sill factor 2? 5.5 meter. Since it is 1, it is 2. So 10 meter below HFL, 12 meter below HFL, 15 meter below HFL. None of this. The score calculation, you see, it is a cube root. This function is a dB square divided by f is a cube function. So without calculating, we cannot say that instead of 11 it will be 5.5 or 10 or anything. We cannot say exactly. So answer shall be none of this. I hope it may be purposeful or may not be. Whatever it may be, I am trying my best to oblige your suggestion, your request, your advice. If any question arises, if any further query, I shall be grateful if you kindly call me at jcgogoi@gmail.com. Again I am saying jcgogoi@gmail.com. Have a nice day, please. My best wishes to you. Stay safe, stay healthy.